Okay, hello everybody, thank you very much for reaching out to this video. Success Promise here, and actually I'm the successful electronics who's post on great electronic content in this video. Actually this video is the part 2. Yeah, actually the part 2 of the transistors. Yeah, I made the first video actually right here. I talked about how a transistor can be used as a switch in that video, but in this video I'm going to be illustrating how you can use a transistor to make an amplifier. Yes, in that old video I actually talked about making a part 2 of this video. Actually the video was too long, so I decided to share it and make it for part 1 and part 2. Actually this is the part 2 of the video, and in this video I'm going to be interfacing with a transistor. Actually, if you want to get the full starting knowledge about transistor, go check out that video part 1 which I talked about transistors. But in this video tutorial I'm going to be using a transistor to act as amplifier, as I said in that my earlier video. So stay tuned to the end of this video. Actually I'm going to be connecting oscilloscope 50 Hz 50% duty cycle square wave to the amplifier to see how it can amplify the wavelength, the waveform, and also I'm going to be amplifying the main audio, as I said earlier, my voice. You're going to love this video and you are going to learn this project and also make this project at your home if you like. Stay tuned to the end of this video and let's go into the tutorials immediately. Okay, now welcome back. Actually now this is the preamplifier. Actually now this is the amplifier using like making the amplifier as making the transistor as an amplifier. Okay, now I didn't connect the circuitry on the breadboard because of normally on the breadboard and also other jumper wire connections, it actually makes a lot of noise and also give me a lot of troubles or a lot of white noise at the output of the speaker. So I didn't make the connections on the breadboard, so I decided to solder it on the very board, which took me half an hour to do, and actually it also assemble everything very good in place so that I can get less noise at the output of the speaker and also a very good project. Okay, now you can see the transistor right here. Actually the transistor is used as amplifier. Now a little tip. Now actually the transistor cannot be directly connected to the speaker. So actually using a transistor as an amplifier is actually using a transistor as a preamplifier. So now actually you can see the positive. This is the power supply line, and this is the output, this is the input of the transistor. This wire is the input of the transistor, and this wire is the output of the transistor. So actually this transistor is going to be connected to the TDA2030 module. Yeah, this is the module which I'm using in this project. I want to use the module in this project. Actually it's a class AB amplifier. Actually it's a very good amplifier you can find on AliExpress, but I'm using the amplifier in this video. I'm going to be connecting the output of this preamplifier into the amplifier so that it can be able to amplify my voice very well, because if I connect directly the output of this output of this amplifier to the speaker, it's not going to sound enough because it cannot really carry the speaker. So actually it needs another amplifier, which I'm using the class AB amplifier. In my case, you can use any other amplifiers if you like. I'm using the class AB amplifier to amplify my audio so that I can have a very good audio that you can recognize too. Okay, now welcome back. Now right now in my screen now you can see that I have two multimeters right here. I got this multimeter from one of the sponsors, and this actually is my brother's multimeter. He also makes electronic projects. You can go check out his channel at the description of this video. I added the link. Okay, now I have two meters right here. This is the oscilloscope meter, and also you can use it to measure voltage and current, and also this meter is actually voltage and current multimeter. Actually this meter I'm going to be using it to create the frequency. Yeah, this is the square wave. Actually I'm going to be turning these to the square wave side. The battery is not yet in. I'm going to turn this to the square wave side so that it's going to produce 50 Hz 50% duty cycle square wave for me. And actually this meter, I'm going to be using this meter to measure the output wave, and also you can see the amplification yourself. So without wasting much time, let's go to the connection process right away. Okay, here you can see here it's produced 50 Hz. Actually it's producing 50 Hz out of this place, and this is the output which is going to be connected to the amplifier circuit. Okay, now welcome back. Actually this is a very simple setup. Don't think it as a big setup. Actually these two probes right here is not connected to anything. As you can see right here, is not connected to anything. I just used it to clip the two terminals of this multimeter. Actually I want to measure the output of the 50 Hz square wave generator. Actually if you want to make a 50 Hz frequency generator, I use a 5 timer. Actually go check out that video up there. And also I also use the arduino to create the 50 Hz 50% duty cycle sine wave. Go also check out that video if you want to make that. Okay, now welcome back to the circuit. Actually now you can see this multimeter. I'm going to use this multimeter to measure the wavelength of this 50 Hz output. Okay, now I'm going to turn it to the wavelength section. Yeah, actually you can see the wavelength right here. I'm going to turn on the light. Yeah, you can see the wavelength right here is actually 50 Hz and it actually produces 1.493 volts. Actually, this is the output of this multimeter which is producing the frequency. I just want to show you the wavelength of it so that when it amplifies you can see the difference yourself. So let's quickly connect it to the amplifier and let's test. Okay, now welcome back. Actually, now the connections are done properly. I know this is actually so kind of tangled, but I'm going to be explaining down detail everything which I connect. Okay, now this is the input of the transistor. Sorry, this is the input of the amplifier. Yeah, this input of the amplifier is actually connected to the 50 Hz output of the multimeter, and actually this is the positive side. This is the power supply of the the amplifier, which is connected to my bank supply right here. I'm using 12 volts to power the circuit, and actually this is the output of the preamplifier, which is connected to the multimeter, which I'm going to be measuring the waveform, and you're going to see how it's improved and the first waveform which I actually showed you. Okay, actually a little short break. Okay, now you can see the output of the preamplifier. Yes, you can see it has improved the waveform. Yeah, the waveform is now increased and it's actually still 50 Hz, and actually you can see that the voltage has decreased to 3 volts. If I use much higher voltage, it's going to increase the waveform more higher, depending. Actually the circuitry is for 12 volts actually, so that's why it's having this kind of power supply. I'm going to be explaining the transistors, how I calculate for the resistors, and also how you can make your own preamplifier later in this video. Actually, now you can see the amplification, and as you can see, the waveform has improved. This is how the preamplifier works. Let's quickly go to the audio check. Yeah, I'm going to be amplifying my voice, and you're going to see the real audio amplification. And yes. Okay, now welcome back. Thank you very much for reaching out. And yes, okay, now this I'm going to be explaining how the transistor amplifies the current, and also how you can calculate for the base resistor, the collector resistor, and also the emitter resistor, and also the capacitors as well. I don't mind about this 9 voltage right here. I'm actually using 12 volt, and don't mind about this transistor right here too. Just a mistake, I'm not using it in this project. Okay, now firstly there is your input capacitor right here. Now this is the input right here. Now when you input your audio through this capacitor work is actually filtering DC out of the signal which is sent, filtering DC and allow only AC to pass as a work of a capacitor, and then it's the base of the transistor. Yeah, the base is connected to the base of the transistor, and as you can see, it's just like it directly goes to the speaker and nothing is amplifying, but the answer is no. Watch this one. You can see 4.7 kilo ohms resistor right here. This 4.7 kilo ohms resistor is connected to the positive side of the battery, and the other side of the resistor is connected to the collector of the transistor. So when audio input is when the audio input passes through this capacitor, filters the DC and allow only AC to pass, it flows like this and goes into the transistor, and then it joins the battery voltage with the audio input voltage which you inputted in the circuit, and connect it directly to the speaker, thereby amplifying your voltage. It's like joining the battery volt and also the voltage. That is how it amplifies the audio, and that is how it amplifies the audio. And actually this capacitor right here filters again DC eruptions like DC signals and allow only AC signals to pass and goes directly to the speaker. Okay, this is the simple way the amplifier works. I know it's a little complicated, but if you just understand the concept, you will get what I'm talking about. It's so easy. And actually there's a potential divider here. Now imagine the audio input audio input voltage which you are inputting into the circuit is lower than 0.7 volt, and thereby cannot be able to turn on the transistor and start working. So the need of these potential dividers, which are actually here, is to keep the transistor turned on even if the voltage which you connect the voltage of the audio input is lower than 0.7 volts, thereby cannot on the transistor. These potential dividers keep the transistor on so that it will still work very well. So it's very important to add a potential divider in your circuit to keep the transistor unstable if you know that your audio input will be lower than 0.7 0.7 volt to turn on the transistor. And also you can see the emitter resistor right here, which keeps the transistor safe and allow the wanted current to flow safely. So this is the formula to calculate for the potential dividers, and also this is the formula to calculate for the audio input capacitor. This is also the formula to calculate for the collector resistor, and also the formula to calculate for the emitter resistor, and followed by the capacitor, the output capacitor calculation. So follow these formulas and put your voltage and you will get the values of the resistor which you're using. If you want to follow my connections right here, I actually use the 12 volt and a 10 milliamps which runs in the circuit. So actually my circuit runs on 12 volt, 10 milliamps peak to peak, and a gain of 10. Yeah, if you're following my sketch right here, you just have to input the amount of voltage. If you reduce the voltage or toggle with the voltage, it's gonna mix things up. So just follow everything I did in this video. If you want to follow the resistors accurately, you have to input the 12 volt and have in mind that the circuit works on 10 milliamps and also have a gain of 10. Yeah, this is how the circuit works, and I hope you really understand what I'm talking about. Let's go back to the explanations of the circuits. Okay, now welcome back. Now I'm going to be talking about the audio check. Now this is the speaker which I'm going to be connecting. This is the 8-ohm speaker which I'm going to be connecting to the TDA 2030 module. Then this is the preamplifier which is connected to the TDA IC, and the output of the TDA is connected to this speaker, and actually the input is connected to my audio out of my phone. I'm going to be playing the music out of my phone. I'm going to be connecting it, and you're going to hear the sound, how it sounds, if it sounds pretty well and pretty amplifies everything. So let's power everything up, and yes, I'm actually using some kind of 10 to 12 volt right here, my power bank, my battery bank. So let's play the music. Can you hear it very clear? This is the 8-ohm speaker. Nice. You can see the bars. Woo! It's warm. Let's go. Woo! Woo! Okay, just a quick tip. Actually, you can increase or reduce the volume using the potentiometer, which is right here. So let's go back to the music. Wow, this is really amplified. I really hope you really enjoyed this video. And actually, I'm going to be going to the amplification using my voice. I'm going to be connecting the mic into the amplifier, and actually you can see how it improved my voice audio. Let's go into that. Okay, welcome back. Now actually the mic, look at the mic right here. This wire is connected to my laptop. I'm actually using my laptop to power the microphone, and actually the input of the preamplifier is connected to the audio output of the microphone, and then the preamplifier is then connected to the AB amplifier, and now you're going to see it. Actually, I'm going to play the audio in the background right now so that you can see how it goes. Testing the microphone, check, amen. Thank you very much. I'm the Successful Electronics. Actually, you can see now I'm using the microphone, and actually the sound is coming from the speaker, and actually is in the background right now. Actually, you can see the amplification, and as you can see, it amplified really well. My voice is really loud, and yes, if I increase the gain of the mic, it is going to make my voice much louder. And I hope you really enjoyed this project. Let's actually go to the conclusion of this video. Yeah. Thank you very much for watching this video to the end. If you really like this video, don't forget to hit the like button, subscribe to this channel, and also support me on Patreon for more educative electronic content like this. Support me on Patreon. You know, when you support your creator on Patreon, you get me fueled up, and I will make more educative content like this for you. Thank you so much for watching this video, and I'll see you in the next one. Peace.